Need to react when your FastMCP server's tools change, but don't want to poll for updates? You'll see how to create a dedicated message handler that automatically responds to tool list changes, keeping your client in perfect sync with the server. The pattern uses FastMCP's built-in notification system, so you only refresh when something actually changes.
From FastMCP import client. From FastMCP client messages, import message handler. Import MCP, types. Class my message handler, message handler. Async def on tool list changed. Self-notification, MCP, types, tool list change notification. To none. Handle tool list changes specifically. Print, tool list changed, refreshing available tools. Client equals client. My MCP server, pi. Message handler equals my message handler.
This demonstrates the observer pattern through a message handler system, where components react to server events without tight coupling. The pattern creates a clean separation between event producers, the MCP server, and consumers, your handler class, enabling reactive programming without polling or shared state. What makes this distinctive is its declarative nature. You define what events matter, not how to listen for them. The system works by routing server messages through a dispatch layer that matches message types to handler methods. Your custom handler subclass acts as a specialized listener, implementing only the hooks it cares about while ignoring others. This design leverages Python's method resolution order and type hints to ensure type-safe event handling, where each notification type maps to a dedicated method signature. This approach solves the problem of maintaining state synchronization between clients and servers in distributed systems. Instead of manually checking for changes or implementing complex pub/sub infrastructure, you get automatic notifications when server resources update. It's particularly valuable for tooling systems, AI orchestration, or any scenario where clients need to mirror server state without constant polling. The trade-off is slightly more upfront structure, but the payoff is cleaner architecture and fewer race conditions. Let's break it down line by line.
From FastMCP import client.
This imports the client class from FastMCP, the primary interface for connecting to and interacting with MCP servers. It handles all low-level communication, message serialization, and connection management, so you don't have to implement the protocol manually.
From FastMCP client messages, import message handler.
This imports message handler, the base class for processing FastMCP server notifications. It provides the interface for handling real-time events like tool list changes, ensuring your application can react to server state updates.
Import MCP, types.
This imports the MCP type definitions, providing strongly typed notification classes like tool list change notification. It enables proper type hints and IDE support for the message handler's parameters.
Class my message handler, message handler.
This defines a custom message handler by subclassing message handler. It implements the observer pattern, letting you react to specific MCP server events like tool list changes. The base class provides the interface, while your subclass adds custom behavior.
Async def on tool list changed.
This defines an async event handler for tool list updates. The async def enables non-blocking processing of notifications, critical for maintaining responsive server operations. This follows FastMCP's notification pattern, where handlers process specific event types asynchronously.
Self-notification, MCP, types, tool list change notification.
This parameter defines the message handler's expected notification type, specifically tool list change notification. The type annotation enforces type safety and enables IDE autocompletion, while the parameter itself carries the actual notification payload containing details about which tools were added, removed, or modified. This is the standard pattern for FastMCP notification handlers, where each handler method receives a strongly typed notification object.
To none.
This is a return type annotation. The none explicitly declares this method returns nothing, making the interface clearer and enabling better static type checking. Python's type system uses this to catch incorrect usage early.
Handle tool list changes specifically.
This docstring documents the handler's specific purpose, processing tool list change notifications. Clear documentation like this enables maintainable event-driven architectures by explicitly declaring each handler's responsibility.
Print tool list changed, refreshing available tools.
This is a placeholder notification handler. It logs tool list changes to the console, serving as a basic implementation stub for the onToolListChanged callback. In production, you'd replace this with actual refresh logic for your tool registry.
Client equals client.
This instantiates the FastMCP client, the primary interface for all server interactions. The client manages the connection lifecycle, handles message routing, and ensures thread-safe communication with the MCP server. All tool registrations and notifications flow through this central client instance.
My MCP server, Pi.
This string identifies the MCP server instance to connect to. FastMCP uses this name to locate the correct server process, enabling multiple independent servers to run simultaneously on the same machine.
Message handler equals my message handler.
This injects a custom message handler into the FastMCP client, overriding default notification behavior. The MyMessageHandler class implements event-specific logic. Here it catches tool list changes to trigger refreshes, ensuring your client stays synchronized with server-side tool updates. This closing parenthesis finalizes the client instantiation, completing the connection setup to the MCP server. It passes our custom message handler, enabling real-time event processing for tool list changes. FastMCP message handling. The message handler class provides fine-grained control over server notifications, letting you respond to specific events like tool list changes without handling every message type. The base message handler already implements all hooks as no-ops, so you only need to override the methods you care about. This pattern keeps your notification logic cleanly separated from your core business logic.
The handler that listens to everything hears only what it chooses to understand.